Hello everyone, welcome to my channel Experience Physics. So this class we have taken up the topic cells and EMF under the chapter current electricity of class 12 physics. Right. Cells and EMF is one of the easiest topic in this chapter. Once again, as usual, let us focus on the problems rather than focusing on the theory content. I will discuss briefly about the theory content and I will jump to solve the problems. Let us try to solve. I think I have brought as many as 28 example problems in this video lecture. Let us try to solve them one by one. To solve the problems, it is one of the easiest topic in the chapter, as I told. To solve the problems, only thing, just knowing Ohm's law and Kirchhoff's law, Kirchhoff's current law and Kirchhoff's voltage law. They are enough to solve the problems in this topic. Right? So let me discuss the theory content briefly. What is a cell? Right. So we know we have used the cell in so many applications. Almost in all electronic applications, cells are used. Right. A cell is a electrochemical unit which converts the chemical energy into electrical energy. Mainly it is used only for storing the electrical energy. Right. So let me draw a cell. Yes. Like this one. This is plus and this is minus. A cell. It may be some company, say 1.4 volt rated. The rated voltage is 1.5 voltage. Right. We will connect some load here. The load. The load may be a lamp or fan or heater. Any electrical load we can connect across the cell, right, to use the cell, right. So this is the cell which is bought in the market, right. So this is the experimental setup of a cell. You know, two electrodes you will have and electrolyte, right. Across the two electrodes you will connect the external load, right. External load, this is the load, external load, and this is the experimental setup, right. So we will not use in our example problems these two diagrams, right. Instead, we will use the symbol of a battery, that is EMF, cell EMF, and this resistance. This resistance is known as internal resistance. This is the two ends of a cell. The two ends of a cell. Let me say A and B. The points A and B of the two ends, right? This is A and this is B. Only we can see the A and B only from the outside. If you want to connect one load, electrical load, to use the cell for your application, you have to connect between the two ends only. This is the electrical load, fan or lamp or heater or any electrical device, right. So this is the equivalent circuit we will be using it. So this is internal resistance, it is known as internal resistance, and all the loads are drawn equivalent as an external resistance. This is external resistance. External resistance means any load, right. So in our example problems, we will have this resistance almost in all the examples, right. This is nothing but the load. This is internal resistance. How this internal resistance is coming here, right. The electrolyte will have some resistance. The electrodes will also have some resistance. Right? These resistance are grouped, right. Their values are lumped up and the equivalent value is lumped up and it is considered as one resistance. It is known as internal resistance. we can't see this internal resistance, right? It is kept or it is available inside the battery. Inside the battery, that is why the name called internal resistance, right? So this is the brief notes about a cell and its internal resistance, right? The EMF. What is the EMF? 1.5 voltage is the rating of the cell. Say this is 1.5 voltage. If I do not connect any electrical load across it, say I have disconnected the electrical load. I have disconnected the electrical load. Then I can measure this 1.5 voltage up to this point. Yes. Up to this point, I will measure 1.5 voltage. If I do not connect any electrical load between the two electrodes, 1.5 voltage will be available. If you buy one battery or cell from the market and if you measure it, it will have 1.5 voltage, right? But if I connect an external resistance like this one, I can't get 1.5 voltage now, right? A voltage which is a bit lesser than this 1.5 voltage will be available across my external resistance. In this case, I will not get 1.5 voltage. Instead, I will have 1.3 or 1.4 only, slightly lesser than. Across the external resistance, I will have one value which is a bit lesser than the rated voltage. Why it is so? Why it is so, right? That means internal resistance will also have some drop when external resistance is connected and the loop is closed, right? In the earlier case, we have not connected the external resistance. This is case 1. Let me draw the two diagrams separately. This is A and this is B. No external resistance is connected here. This voltage is 1.5 voltage. This full voltage I will get between the terminals A and B because this is one open circuit. No current is flowing through it. So no current means across this resistance, no voltage drop. Ohm's law, V is equal to I into R. Since I is equal to 0, the voltage across the resistance, so this is plus, okay, any 0 voltage. No voltage is available here, 0 voltage. That means full voltage 1.5 voltage I will measure between the terminals A and B. But here, in this diagram, I have connected the external load across my cell. Yes, across my cell I have connected the external resistance or external load, right? Now a current is flowing through it. A current I amperes. I ampere is flowing through it, right? Then only the external device or external resistance will work. If it is a lamp, it will work. If it is a fan, if it is a heater, they will work because I is flowing through it. In this case, it is an open circuit, no current flows through it, no drop across this resistor, so full voltage is available or measured between the two terminals A and B, 1.5 voltage, yes. But here the current is flowing through it, the current entering terminal through this internal resistance is marked as plus and leaving the terminal is marked as minus and some voltage. Say R is the internal resistance value, say capital R is the external resistance value. I into R according to Ohm's law will be the drop. I into R, right? So this is 1.5 voltage. Some drop is detected, subtracted from here, say 1 voltage. 1 voltage, say 1 voltage. So this is plus and this is minus 1.5 voltage rated value. Minus are available nearby the like terminals are available. So I have to subtract the value. 1.5 voltage minus 1 voltage will be the net voltage measured between the two ends A and B. That is why when external resistance is connected, a voltage is reduced between the two terminals or two electrodes. Between A and B, the voltage is reduced because of the current flowing through the external resistance, right? When the current flows through the external resistance, drop will also occur across the internal resistance. This internal resistance is eating some voltage, eating its own voltage. 1.5 voltage is the cell value, but it is the internal resistance which is available inside the battery is eating some 1 voltage, and it is giving to the user just 1.4 voltage only in our case, right? So EMF, we will use the symbol E, and when it is available, the voltage which is available to the external resistance, in this case also A and B, in this case also A and B, this voltage, because this is a short circuit, so this is named as terminal voltage. This is EMF, E, that is the rated voltage which is printed in the battery, rated voltage EMF. When it is connected with an external resistance, the voltage will be somewhat reduced. That reduced voltage will be known as terminal voltage, and to mean it, V is the symbol we will use in these problems what we are going to take up, right? So E will be greater than V usually, right? E will be greater than V. In most of the application, this is correct, right? Let us solve the problems one by one, right? In the given figure, the first one, in the given figure, internal resistance of the cell is, right, 1.5 voltage, EMF value, 0.2 ampere is flowing through the external resistance, 5 ohms, right? This is closed. Small r is the internal resistance value. The question is to find the internal resistance. What is the value of R? I is available, voltage is available, right? Terminal voltage, these are the two terminals. Battery terminals are the electrodes. A and B are the electrodes. Between the two electrodes, we are connecting the resistance, right? This is V. Terminal voltage V. I into R. I is available, R is also available. Ohm's law directly I can apply. 5 into 0.2, 1 voltage. 5 into 0.2 is equal to 1 voltage, right? So this is 1.5 voltage. The current is flowing through the external resistance in this direction. The current is entering the internal resistance here and leaving here. What is the value of current? 0.2 amperes. What is the value of terminal voltage? 1 voltage. This is 1.5 voltage. So 0.5 voltage, E minus V. 0.5 voltage is the voltage which is eaten by the internal resistance. 0.5 voltage, right? Current value is now known, 0.2 ampere. V is known, I is known, R can be easily found. Resistance is equal to V by I. VR, I can write VR to mean the 0.5 voltage. VR is equal to 0.5. Voltage developed or voltage dropped across the internal resistance. VR is 0.5 voltage, current is 0.2 amperes. This is 5 by 2, 2.5 amperes, 2.5 ohms. 2.5 ohms is the answer. Yes, next one. The potential difference in open circuit for a cell is 2.2 voltage. Open circuit. So in open circuit means E value is available. When a resistor 4 ohm is connected between its two electrodes, the potential difference becomes 2 voltage. When external load is connected, the voltage is dropped. That means V is equal to 2 voltage. The internal resistance of the cell, what is it? This is the diagram. circuit diagram, external resistance, right, 4 ohms, 2.2 voltage, R value is watt. The voltage is becoming 2 voltage. So between the 4 ohms, so easily we can find the current through 4 ohms. So that is the only current which is flowing in the circuit, V divided by R. So I is equal to V divided by R, 2 by 4 is equal to 0.5 amperes. I is equal to 2 by 4, 0.5. 0.5 ampere is flowing through the circuit, 0.5 amperes. Current entering terminal plus, leaving terminal minus. This is 2.2 voltage. When external resistance is connected, it is coming down to 2 voltage. That means 0.2 voltage is eaten by the internal resistance, 0.2 voltage. Internal resistance is consuming 0.2 voltage, right? So R is equal to Ohm's law, V by I, VR. To mean it is the voltage developed across the internal resistance. VR, I am writing VR, 0.2 divided by 0.5. This is 2 by 5 is equal to 0.4 ohms. The answer is 0.4 ohms. Option D, right. So next problem. Two cells are connected in series as shown in figure. The potential difference between the terminals A and B of the combination is, two cells are connected in series, right? So usually the cells will be grouped either in series or in parallel, right? If they are connected in series, the voltage will be added. 5 voltage, 6 voltage. We know we have used in the torch light. 2 or 3 cells we have connected one by one in series to get more voltage to glow the lamp, right? Accordingly, 2 EMFs, 5 voltage and 6 voltage, right? Their internal resistance, R1 is equal to 3 ohms and R2 is equal to 2 ohms. The external load has a resistance of 5 ohms. The question is the potential difference between the terminals A and B. This is one cell and this is another cell. 2 cells are connected here. When a number of cells are grouped, the combination is known as battery, right? Separately, it is known as cell. When some cells are connected either in series or in parallel, then the combination will be called as a battery. So this a battery setup, 5 voltage and 6 voltage, their internal resistance are 3 ohms and 2 ohms, external resistance 5 ohms. Let me draw the circuit diagram separately. By mentioning the internal resistance in the diagram also. Yes. The value is 5 ohms external resistance, R1 3 ohms, E1 5 voltage, E2 6 voltage and R2 2 ohms. The potential difference between the terminals A and B. Easy. So this is the battery. What is the voltage, terminal voltage of the battery if 5 ohms is connected? So this is one current which is flowing through the external resistance. Once it is known, I into R will be the value. That's all, right? So how many sources? 5 voltage and 6 voltage. Totally 11 voltage. I can write it as a single cell of having 11 voltage, plus minus. So you have to be very careful by looking at the polarity, right? 5 and 6, their values can be added, plus minus. This is 3 ohms and 2 ohms, they are in series. So 5 ohms. This is 5 ohms, external resistance. 11 divided by 10, 11 divided by 5 plus 5 series, 11 divided by 10, 1.1. The current through it is 1.1 amperes. Ohm's law. 1.1 ampere is the current which is flowing through the external resistance. I into R, 1.1, this is A and this is B. The question is the voltage between A and B, potential difference between A and B, 1.1 into 1.1 into 5, 5 into 1.1, R into I, that is the V, VAB, a 5.5 voltage will be the answer. VAB 5.5, yes, 5.5 voltage will be the answer, yes. Next one, when a resistance of 2 ohms is connected across the terminals of a cell, the current is 0.5 amperes. When the resistance is increased to 5 ohms, the current is different value 0.25 amperes. The EMF of the cell is what? What are the other data? When a resistance of 2 ohms is connected across the terminals of a cell. A cell, it is internal resistance. This is 2 ohms. The current is 0.5 amperes. When the resistance is increased to 5 ohms, let us increase the value to 5 ohms. The current is 0.25 amperes. The question is the EMF of the cell. What is the value of E? Same cell. So E and R are same. EMF is asked. So we have to remove resistance, internal resistance. If we cancel internal resistance, we will get the answer. Right? So Ohm's law. I is equal to V divided by total V divided by total R. That means I is equal to total voltage is E, total R is this external resistance plus this value 2 plus R. This way we have to write, right? So I is equal to insert R, let me write R here, right? So I is equal to 0.5 amperes. E, say R value is 2 ohms plus internal resistance is unknown. Here I is equal to 0.25. E is same. This value is 5. External resistance is 5 plus R. So equation number 1 and equation number 2. Let me divide this way. 1 by 2 is equal to 0.5 divided by 0.25, which is equal to E divided by 2 plus R upon E divided by 5 plus R. 0.5 divided by 0.25, 2. E is removed, 5 plus R will go up, divided by 2 plus R. Cross multiplying 4 plus 2R. Is equal to 5 plus R. 2R minus R is R, 5 minus 4 is 1. So R value is 1. But the question is to find the value of E. So R value, let us put it here. In this equation, I am going to put the R value. 0.5 is equal to E divided by 2 plus 1. 3. 3 into 1.5. 3 into 0.5, 1.5. So E value is 1.5 voltage. 1.5 voltage is the answer. Yes. Right. Here, a set of n equal resistors, each of value R, are connected in series to a battery of EMF E and internal resistance R. A set of n equal resistors are connected in series, right, to a battery of EMF E and internal resistance R. Battery and internal resistance R connected in series means this way, R, n values. So that means in series connection we will add NR. The current drawn is I amperes. Now the n resistors are connected in parallel to the same battery. Same battery E or n resistors are connected, R, n resistors are connected. The equivalent value will be R by n. In parallel connection, R by n. Now the current drawn from the battery becomes 10 I amperes. 10 I amperes. Then n is equal to what? N is what? Right. So I is equal to the same formula we are going to use. I is equal to E divided by R plus R. This is the standard formula we will use, but here this is NR. Instead of this internal resistance, I will write R here. Right. The first one, let me write here. I is equal to E divided by NR plus another R. Here the current is 10I E divided by R by N plus R. R by N plus R, which is equal to, this equation is 10I is equal to E divided by, if we take LCM as N, NR plus R divided by N. This is equal to N into E divided by NR plus R. The value is 10I. Right. You compare the two equations here. NE divided by NR plus R is equal to 10I. E divided by NR plus R is equal to I. Right. I is equal to E divided by NR plus R. E divided by NR plus R is equal to I. 10I is equal to NI. N is equal to 10. 10 is the answer. Option A. Here, two cells, each of EMFs 3E and 6E are connected in series to external resistance R. 3E and 6E are connected to an external resistance R. Their internal resistance of 3E is R1 and that of 6E is R2. Yes. The value of R, what is the value of R? At which the potential difference across the terminals of the second cell becomes 0. At which the potential difference across the terminals of the second cell. Second cell potential difference must be 0. Let me draw the same diagram by including the internal resistance explicitly. Explicitly we will draw. R2, this is 6E, R1 3E, and this is R. The question is, what is the value R such that this voltage become 0? The potential difference across the terminals. Right. These are the terminals. Terminals, second cell. Terminals of the first cell. Terminals of the second cell. Right. So to make this voltage to be 0, this is 6E, right? If I have another 6E with opposite polarity, this 6E and the 6E will get cancelled this way. Say this is A and this is B. What is the voltage between the two terminals A and B? This is 6E. If it is also 6E, plus minus minus plus. So the voltage will be 0. That is the concept. To have the voltage across this cell to be 0, I must have a battery of or an equivalent voltage across R2 as 6E with opposite polarity, right? With opposite polarity. If it is also 6E with opposite polarity, this voltage will become 0. That is the concept, right? What is the voltage across R2? In this diagram, the voltage across R2 is, say this is I amperes. I into R2, this is plus, entering terminal plus, leaving terminal minus. I into R2 will be the voltage across the internal resistance R2, always. I into R2. I into R2 must be 6E. That is the idea. I into R2 must be 6E. Obviously, this will be plus and this will be minus because the current is flowing through the external load in this direction only. The current is entering R2 in this terminal and leaving here. So plus minus. Automatically you will get this polarity, and if it is 6E, okay, fine. 0 will be the voltage or potential across the two electrodes of the second cell, right? So I R2 must be 6E, right? Then the question is to find R. We have to include R in our calculation. How to include R? Right. We have to find what is I. I is equal to net voltage is 3E plus 6E, 9E. These two are in series, plus minus 9E divided by total resistance R1 plus R2 plus R. Three resistors are here. R1 plus R2 plus R, right? Let me draw in the next page. IR2 is equal to 6E. I is equal to 9E divided by R1 plus R2 plus R. Let me put this I here. So this equation will become, instead of I am writing 9E R1 plus R2 plus R is into R2 is equal to 6E. So E I can remove. So 9R2 is equal to cross multiplying 6R1 plus 6R2 plus 6R. The question is to find the value of R. The value of the chosen value of R. The chosen value of R, yes. The question is the value of R at which the potential difference across the terminal of the second cell becomes 0, right? What is the value of R such that this voltage is becoming 0? So the question is to find the value of R. Let me write 6R here. So 6R is equal to, this is 9R2 minus 6R2 is 6R2. This is minus 6R1. Then R is equal to 6 by 6 R2 3R2. Yes, this is 3R2. 9 minus 6. R is equal to 3 by 6. This is R2 by 2 minus R1. That is the answer. 3 by 6 minus 6 by 6. So R is equal to R2 by 2. This is R. R2 by 2 minus R1. R2 by 2 minus R1. Option C is right. So the concept is to make the entire voltage across one cell to be 0, the voltage across the internal resistance must be the EMF of that particular cell. That is the one. Yes, here a cell of EMF gives rise to currents I1 and I2, two currents in the circuit when external resistances R1 and R2 are connected respectively with that cell. The internal resistance is what? So similar problem we have solved using the numbers. Now they are asked in a equation format, right? Using some numbers we have solved one problem. Two currents I1 and I2 when the value is R1 and R2, right? The cell of EMF gives rise to two currents I1, I2. The two resistance R1 and R2. The question is internal resistance is what? E and R, this is R1. This is I1. Same cell, we are connecting two different resistances. E and R are same. The options given are R is equal to I1 R1 minus I2 R2 by I2 minus I1. I1 R2, drop minus current. Drop divided by currents. Drop divided by currents. Voltage divided by currents, right? So as usual we will find what is I1. I1 is equal to E divided by R1 plus R. Here I2 is equal to E divided by R2 plus small r. So the question is to find the internal resistance. So we have to remove the E. I1 by I2, I1 by I2, equation number 1 and equation number 2. This is 1 divided by 2. Equation 1 divided by 2. I1 by I2 is equal to E divided by R1 plus R divided by E divided by R2 plus R. E I am removing. So this is R2 by R, R2 plus R divided by R1 plus R. So what is the format? Let us once again check what formats they are given. They are giving in the options. I1 R1 minus I2 R2, I1 R2 minus I2 R1, I1 R1 plus I2 R2. Accordingly, we have to make some changes here. So we have to bring I1 R1 cross multiplying it, I1 R1 plus I1 R, which is equal to I2 R2 plus I2 R. So R value is asked I1 R1 minus I2 R2 is equal to I2R minus I1R. This is R of I2 minus I1. Left hand side same. Then R is equal to I1 R1 minus I2 R2 divided by I2 minus I1. Yes, the result is obtained. I1 R1 minus I2 R2, I1 R1 minus I2 R2, I1 R1 minus I2 R2 divided by, this is I1 R2. Yes, this is wrong. So this is right. I1 R1 minus I2 R2 divided by I2 minus I1. I1 R1 minus I2 R2 divided by I2 minus I1. So option A is the answer. Here, so this problem is very interesting. A car battery has EMF 12 voltage and internal resistance 5 into 10 to the power minus 2 ohms. If it draws, the current is 60 amperes, then terminal voltage of the battery is what? Yes, the question may look straightforward, but you will be trapped in this problem. E is equal to 12 voltage. R value is 5 into 10 to the power minus 2 ohms. I is equal to 60 amperes. If you give the current direction this way, this is wrong. Almost in all the problems we are giving this current direction from the positive terminal. The conventional current direction is away from the positive battery, but in this problem we should not take this way of current direction. Why? It is drawing 60 amperes. The car battery is taking 60 amperes. That means the current is flowing into the battery. It is flowing into the battery, not flowing away from the conventional. Again, it is conventional current direction, right? Conventional current, it is flowing towards the battery. That means the car battery is in charging mode. In this case, the battery is in charging mode. In all other problems, what we have considered so far, they are in discharging mode. They are supplying the voltage or the energy to an external load. But here, this is the battery is acting as a load and it is drawing some electrical supply, electrical energy from an battery charger, right? Like EV vehicle, e-vehicles, right? It is taking the current. Now the current is flowing into the EMF, right? So this is the way current is flowing. Here the current is flowing in this direction. What is R value? 5 into 10 to the power minus 2. 60 ampere. So what is the voltage here? I am going to find what is the voltage here. Voltage across the internal resistance VR. I into R. 60 into 5 into 10 to the power minus 2. 60 into 5, 300 into 10 to the power of minus 2. 300, 2 zeros, 10 to the power of minus 2. The voltage is 3 voltage. Voltage across the internal resistance is 3 voltage. What is the EMF of the battery? 12 voltage. This is plus minus, plus minus, plus minus, plus minus are kept nearer. That is minus and plus are kept nearer. So we must add the two voltages. 12 plus 3, 15 will be the answer. Option A is the answer. If you take this direction, you will have to write the answer as 12 minus 3. 12 minus 3, 9. If you write 9 as answer, it is wrong. You will lose 5 marks, right? It is in charging mode. What is the hint whether it is in charging mode or discharging mode? Draws. The key word is draws. It takes. It does not deliver. It takes the current. 60 ampere. The source is some other means. It is a charger from the charging station or in your home, right? You are giving the supply to the battery. Right. Next one, two sources of equal EMF are connected in series to an external resistance R. Two sources of equal EMF are connected in series. Two sources of equal EMF are connected in series. The internal resistances of both the sources are R1 and R2. R1 and R2. This is same. Equal EMF. EMF is same, but these values are different. R1 and R2. It may occur in some cases. If you use different company cells, this is company A and this is company B. Do different companies you are connecting in series. So their internal resistance may differ, right? The internal resistance of both the sources are R1 and R2 such that R2 is greater than R1. That is one condition they are giving. If the potential difference across the source having internal resistance R2 is 0, this voltage, this is another condition. Condition number 1, R2 is greater than R1. Condition number 2, this must be 0, right? Then, what is this value of R? R must be one of the options. This is E, this is E. Equal EMF. Internal resistance are different. R1, R2. R2 is greater than R1. But they are same. R has not been changed. R is same, right? So this is only one case. We must make this voltage as 0. What is the value of R which is making this second EMF or second cell, the voltage across the second cell to be 0, right? R2 minus R2 is greater than R1. That is the condition, right? Let me take it. Let me draw the diagram here. E R1, E R2, and this is R. R1, R2, E, E. The condition is to make this voltage as 0. Already we have discussed this concept. To make this voltage 0, this drop across this resistance, this internal resistance must also be equal to E, right? That means I into R2, the current is flowing this way, plus minus I amperes, I into R2, I into R2 must be equal to E. Plus minus plus, cancelled, 0 voltage. I into R2 is the voltage drop across it according to Ohm's law. Right. I into R2 is equal to E. So that is the concept we are going to use. Then write what is I. I is equal to E and E in series 2E divided by R1 plus R2 plus R. R1 plus R2 plus R. This is I into R2, which is equal to E. We have to find what is R. So E I can remove. R1 plus R2 plus R is equal to 2R2. Cross multiplying, R1 plus R2 plus R is equal to 2R2. R is equal to 2R2 minus R2. R2, this R1 minus R1. R value must be R2 minus R1. R2 minus R1. That must be the answer. Yes, option D. R is equal to R2 minus R1. Some logically you can arrive at this answer immediately. R2 is greater than R1. This is one condition they are giving. We know the external resistance must be a positive number, right? R1 plus R2. It won't affect whether R2 is greater than R1 or R2 is smaller than R1. So this will not be the answer. Here R1 plus R2. This will not be the answer because the value, this condition is not at all required if this is the answer. Here R is equal to R1 R2 divided by R1 minus R2. R2 is greater than R1. If R2 is greater than R1, this will be negative value. So this should not be the answer. Automatically this must be the answer. R is equal to R2 minus R1, right? So for the answers A and B, this condition is not at all required. R1 plus R2, yes, it may be true. R1 plus R2, it may be true. Why they are giving specifically this condition? The answer must be one of the two answers, C and D. If you put R2 is greater than R1 here, if you substitute the condition here, this will be negative value. R should not be negative value practically. This is also not true. So the answer should be D. Yes, R is equal to R2 minus R1. Yes. Here, a battery consists of a variable n identical cells having internal resistance R each. N identical cells. N identical cells we are having. Internal resistance R each. Connected in series. The terminals of the battery are short circuited. The terminals of the battery are short circuited. And current I is measured. Which of the graphs shows the correct relationship between N and I? Number of cells and current flowing through the series circuit. Among the four graphs, which one is the correct one? Which one is the correct one? So, N identical cell, the current is measured, right? Let me take N is equal to 2 first. It is short circuited. That is the important point. The important point is the short circuit. The important point is the short circuit. In this problem, the key word is the short circuit. E or E or. Let me have some numerical values. Yes. Say this is 5 voltage, this is also 5 voltage, say 2.5 ohms, 2.5 ohms. What should be the current? I is equal to 5 plus 5, 10, 10 divided by 5, 2.5 plus 2.5 is 5. So 10 divided by 5 ohms is equal to 2 ampere. Let me have another circuit. Here N is equal to 3. N is equal to 3. 3 cells we have connected in series. 5 plus 5 plus 5. I is equal to total voltage 5 plus 5 plus 5 is equal to 15. 2.5 plus 2.5 plus 2.5 because all are identical. 2.5 plus 2.5 plus 2.5, 7.5. 2 amperes. In both the cases, the current is 2 amperes. It does not change. Let me take another one example. Let me have 4 cells. Cell 1, cell 2, cell 3 and cell 4. Short circuit is important. No external load is connected. The battery terminals plus and minus are short circuited. 5 plus 5 plus 5 plus 5, 20. Voltage is 20. V is equal to 20. R is equal to 2.5, 2.5, 2.5, 2.5, 10. I is equal to 20 divided by 10, V by R, again 2 amperes. So, N I am changing 2 cells, 3 cells, 4 cells. N can be any number if they are short circuited. The current will not change. The current is constant. Option A is right. Here, in this problem, a voltmeter with resistance 500 ohms. Voltmeter with resistance 500 ohms. Ideal voltmeter is an open circuit. Ideal voltmeter is open circuit. That means infinity resistance. Practical voltmeter will have some resistance. This is practical voltmeter. Is used to measure, what it is doing is used to measure the EMF of a cell of internal resistance 4 ohms. EMF, internal resistance, this is 4 ohms, this is E, and let me draw the voltmeter here. This is voltmeter. This voltmeter is having 500 ohms. This may be drawn as this familiar circuit like this one. This is 4 ohms and this is 500 ohms. This is E. The voltmeter is measuring the voltage between the 2 electrodes or 2 terminals. That means the voltmeter is measuring the terminal voltage. It is measuring the terminal voltage, right? If it is an open circuit, E will be the answer. But here, the practical voltmeter, since it is having some ohmic value, resistance value, it is used to connect for the purpose of measuring the voltage. But since it is having some own resistance, 500 ohms, it is closed circuit. If it is an ideal voltmeter, infinity resistance will not be a closed circuit, open circuit, but such experiment setup cannot be done in practice, right? Because the practical voltmeter will have some ohmic value. This ohmic value will consume some current. Its own working, it will consume, it will require some energy. So, definitely it will consume some current through it, right? So, that is the case. Practical case we are discussing here. 500 ohms, this is 4 ohms, this is EMF. The percentage error, the question is to find the percentage error in the reading of the voltmeter, right? This is E. The voltmeter will measure V, isn't it? Between the electrodes only we will connect the voltmeter, right? So, this is E and this is V. The error will be the difference between E and V. Yes, error is percentage error E minus V for the given E into 100. E minus V is what? E minus V is nothing but this drop. This is E minus V. E minus V is nothing but this voltage drop across the internal resistance, right? So, this is IR, I into R. E minus V is nothing but I into R divided by E into 100. What is I? We have a familiar expression E divided by R plus R. Here E is not given, R is given 500 ohms. This is the external value, external resistance value 500. Actually it is not a load, it is used to measure the voltage only, but once it is connected here, it acts as a load because it is drawing the energy from the cell. 500 plus R is equal to 4, 504. I is equal to E divided by 504. I is equal to, let me write, I is equal to the familiar expression R plus R into R divided by E into 100. So E I am removing. So this is R divided by R plus R into 100% error. So let me write here R is equal to 4. R is equal to 4 divided by R is equal to 500 plus 4 into 100. This is percentage error. This is 400 divided by 504. If it is 400 divided by 500, approximately, if I write 504 as 500, 0, 0, 0, zeros, 4 divided by 5 is equal to 0.8. In fact, this is percentage error, percentage error, percentage error. So 0.8% is the answer. 0.2, 0.8, 0.8% will be the answer. So nothing wrong if you approximate 504 to 500. In the problem itself, they have mentioned you can do the approximation, will be nearly. Yes, the answer may be nearly 0.8%. What is the percentage error? Nearly what is it? Right. Here, n identical cells, each of EMF E and internal resistance R are joined in series to form a closed circuit. The potential difference across any one cell is what? This is only a conceptual problem. Conceptual problem. N identical cell. Cell 1 R, cell 2 R. Identical means its internal resistance will also be identical. R, R, E, E. To form a closed circuit, that means no external resistance is connected. They are themselves forming a closed circuit, plus and minus. It is one battery. A group of cells are connected in series. The plus, the first terminal, the plus terminal of the first cell is connected to the negative terminal of the last cell, short circuited, right? The potential difference across any one cell will be what? Any one cell. This is always 0. How? We will see. This is 2E. I is equal to n. I have considered n is equal to 2. Just for discussion, n you can assume any number. I is equal to 2E divided by 2R. So I is equal to E by R. I is equal to E by R. Right. So I into R is the drop across it. I is equal to E by R into R. The R and R will get cancelled. So E is the voltage drop developed across E. Similarly, E is the voltage drop developed across E. E and E will get cancelled because plus minus minus plus, plus minus minus plus. Any one cell across all the cells, if you measure the voltage across all the cells, you will get 0 is the answer because a short circuit is made, right? Let us assume 3 such cells or n is equal to 10. Assume 10, n is equal to 10. So I is equal to 10E, 10 cells, 10E divided by 10R. Again E by R, I value is E by R. Then IR is equal to E by R into R cancelled, E is the answer. IR is equal to E. across the internal resistance, E will be the voltage drop which is coming. E and E are cancelled, right? So 0 is the answer. If the internal resistance value are different, like one problem we have just now considered, two different company cells, if you R1 and R2, assume this is R1 and this is R2, in this case you will not get 0 here, but here you will get 0. Across the battery, across a single cell you will not get 0 value, but across the battery group of cells, across the battery, because this is a short circuit, we know voltage across a short circuit is always 0, right? In this case, you will not get 0 independently across each cell. But for identical cells, independently 0, 0, 0, 0 across each cell, we will get 0 as the answer. The same concept is used here. Let us read the problem statement. 8 cells marked 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. EMF 5 voltage. 5 voltage. Each cell is having 5 voltage, 5 voltage, 5 voltage. The internal resistance is 0.2 ohms. All are having internal resistance 0.2 ohms. Internal resistance they have not mentioned in the diagram. What is the reading of the ideal voltmeter? Look at the word ideal. Ideal voltmeter V. That means the voltmeter is an open circuit here. It does not have any internal resistance inside the voltmeter, right? That means ideally the voltmeter does not draw any current for its working. Practically very, very minimum. They are neglecting in this problem, that's all, right? So I can redraw the circuit, but just now we have discussed the concept 0 will be the answer, right? Across any one cell, 0 will be the answer. Yes. This concept. Across any cell, n can be any value. Here n is equal to 8. All are connected. If you remove the voltmeter, and if you look at the circuit, all are connected and they are forming a closed circuit, right? Let me draw this diagram. According to the concept what we have discussed in the previous problem, across any one cell, 0 is the answer. 0 is the answer, option D, right? Anyway, we will draw the entire circuit and discuss it elaborately. This is first battery or first cell, cell number 5 in fact. Minus plus. Look at the polarities also. Plus minus, 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 plus minus. Yes. Then plus minus, plus minus, plus minus, yes. 1, 2, 3, plus minus. Only one cell here, then 3 cells are here. Okay, 1, 2, 3, 4, 5, 6, 7, 8 cells. Their EMF are 5 voltage and this is 0.2 ohms internal resistance. 5 voltage, 0.2 ohms. All are 5 voltage, 0.2 ohms. Let me mark the 2 points where voltmeter we have connected, A and B. This is the place where the voltmeter is connected, A and B. I am measuring the voltage across only one cell, right? A and B. This voltage is the question. Already according to the concept what we have discussed in the earlier problem, we have straight away written 0 is the answer. We will prove the 0 is coming again in this problem, right? 5, 5, 5, 5, 5. across this A and B, we can draw this circuit. This is grouped. The 7 cells are grouped and A and B is kept here. A, B, the 7 into 5, the single cell is having 5 voltage, 0.2 ohms. The 7 are having 7 into 0.5, 3.5. 7 into 0.2, 1.4 ohm. So now the question is, what is the voltage between A and B? Between the 2 points A and B, what is the voltage? Right? 3.5 plus minus plus minus. So the voltage can be added. 3.5, it is not 3.5, 35. Right? 7 cells. 35. So this is 7 into 0.2, 1.4. 35 plus 5, 40. 1.4 into 0.6, 1.4 plus 0.6, 1.6. So total EMF value is 40. The current I can straight away find using Ohm's law. 35 plus 5 is 40 divided by 1.4 plus 0.6, 1.2, 1.4 plus 0.2, 1.6. So this is 40 divided by 1.6. Let me write 400 divided by 16. So 8 table, 2 8s, 5 8s and 50. 50 divided by 2, 25. The current value is 25 ampere. 25 ampere is circulating in this circuit. It is a series one or closed circuit. 25 ampere is circulating, and we are connecting one voltmeter across only one cell, and we are trying to measure the voltage across it. What we are going to find, right? So 25 amperes. So from here 25 ampere is coming. 25 amperes. This is the bigger one. That is why I am taking this direction of current. 35 is bigger than 5 voltage, right? No. Anyway, these are minus plus minus plus. This must be the direction, right? 35. We have added 35 plus 5, 40. Yes. 25. Entering terminal plus leaving terminal minus in the 0.2 ohms. Current entering here, leaving here. 0.2 into 25 will be the 5 voltage. This is also 5 voltage. This is also 5 voltage. Plus minus minus plus. 25. So 25 ampere is circulating here. 25 ampere enter 0.2 ohms here. 5 voltage is the drop across the single internal resistance. Its own EMF value is also 5, plus minus minus plus. So this 2 voltage get cancelled themselves. So we will see here also. 25 amperes into 1.4 ohms. 25 into 1.4 is equal to 35. Entering terminal plus, leaving terminal minus. Plus minus minus plus. This will also be, if you connect, yes, this is a short circuit. Right. If you connect the voltmeter across any one cell or across any 2 cells or across any 3 cells, if the EMFs are, if the cells are identical, you will get 0 is the answer. So that is the concept we have discussed previously in this problem. Yes, conceptual problem. Yes, next one. What is the value of an external resistance when power transferred by a cell to its maximum? Yes, EMF, internal resistance, what must be the external resistance? This is one theoretical problem. So maximum power transfer theorem is available. I have not taught you the theorem, but the condition for R, the condition, because I am focusing the examples much, the condition for maximum power transfer is R must be equal to the internal resistance. Very simple. If the capital R and the small r are equal, this cell will transfer maximum power to the load, external resistance. If R is slightly greater than R, or if R is slightly less than R, it won't happen, right? Exactly if R is equal to R, a proof is available. In your textbook, you can see the proof. Capital R must be equal to small r. That is the condition. So the condition for maximum power transfer in a circuit is capital R is equal to small r. R is the internal resistance, right? Option C is the answer. Right. This is also from maximum power transfer. The maximum power drawn out of the cell from a source is given by what? Power is asked. In the previous problem, what is the condition? R must be what value? But here, what power is now transferred? E, this is R and this is R. What is the condition? R must be R, where R is the internal resistance and E is the EMF. R must be R. Now, what is the maximum power? The maximum power is the question. P is equal to what? It sends one current I. We know P is equal to I square R. Here R is equal to R. So I square small r. I have used the condition R is equal to R, P. Then I is equal to what? From Ohm's law, E divided by R plus R, or according to the condition small r, R plus R, 2R. This is I square R. Then this is E square divided by 4R square into R. Then one R I am removing, E divided by 4R will be the answer. E square divided by 4R. E square by 2R, E square by 4R. Option B is correct. E square by R, this is E square by 3R. To draw maximum current from a combination of cells is used to have higher current rating or higher voltage rating. How should the cells be grouped? If the cells are connected in series, the voltage will be added. E2, E3, E4, If they are connected in parallel, more current. Each cell will give one current. So the currents will be grouped. Currents will be added. To have higher current rating, like in the UPS, what we are using in our home applications, UPS, the cells will be connected in parallel to have higher current rating, to work more loads, 2 fans, 4 lamps, etc. Right? To draw maximum current from a combination of cells, how should the cells be grouped? Series, maximum current. Series, wrong. For maximum current, it must be parallel, isn't it? Right. But this is also wrong. Look at the other options. Mixed. Mixed means what? Depends upon the relative values of external and internal resistance. Why? To draw the maximum current, what is the condition? The external resistance must be equal to the internal resistance. The external resistance must be equal to the internal resistance. So, depends upon the relative values of external and internal resistance, maximum current, right? So, in the previous problem, we have seen it. I square R, I is equal to E divided by 2R the whole square R. 2R, how we have written? Using this condition, maximum power transfer theorem condition, right? So, this option is right. Depends upon the relative values of external and resistance. If you wrongly type or if you wrongly mark option B for parallel, more current, it is wrong. the current flowing through the 5 ohm resistance in the network as shown in figure is what? So this is two cells which are connected in parallel, then across them a 5 ohm is connected, parallel connection. So far we have considered series connection problems. Now it is a parallel connection problem, right? E1, E2, R1, R2, a 5 ohm is the external resistance, right? One formula it is available for the parallel connection. In series connection the EMFs can be added, 1E, 2E, 3E, 4E if they are identical. Similarly the internal resistance can be added. In parallel connection, finding the equivalent resistance value is easy. R1 R2 divided by R1 plus R2. This formula R1 R2 divided by R1 plus R2. But if the voltage value is they are dissimilar, it is 20, it is 10. They are dissimilar, unequal values. If they are identical values 20 into 20 or 10 into 10, it is easy. The equivalent value will also be in a parallel connection equal value. If it is 20 and 20, it is easy. But it is 20 and 10. For unequal values, we have to use one formula. You please remember this formula, equivalent EMF value. Equivalent EMF value. Sigma E by R divided by sigma 1 by R. Sigma E by R divided by sigma 1 by R. Then R equivalent is easy. E by R, let me write it as small r. Yes. Sigma E by R divided by sigma, sum of E by R divided by sum of 1 by R, reciprocal, right? So dimensionally also you will get correct answer. R and R will get cancelled. So E and E, left hand side is equal to right hand side, dimension is tallied, okay. R equivalent for parallel combination. Yes, we have used this formula in so many problems. R equivalent is equal to R1 R2 divided by R1 plus R2, right? So I am going to draw one equivalent circuit this way. This is my idea. This is external resistance, R is equal to 5 ohms. Here, two EMFs and two internal resistance, but I need an equivalent value of E equivalent and R equivalent. So this is what I am going to find. R equivalent is R1 R2 divided by R1 plus R2. 2 into 1, 2 into 1 divided by 2 plus 1, 2 by 3. So this is 2 by 3. E equivalent, let us find here. Sigma E by R, sum, two cells, 20 by R, E1 by R1 is 2 ohms, plus second cell, 10 by 1 divided by sigma 1 by R, 1 by 2 plus 1 by 1 is equal to 20 by 2 is 10 plus 10 by 1 is 10 divided by 1 by 2 plus 1 by 1. This is 1 plus 2 by 2. This is 20 divided by 3 by 2. That means 40 by 3. This E equivalent is 40 by 3. 40 by 3, 2 by 3. This is 5 ohms. Now question is current flowing through 5 ohms. This current is asked. 40 by 3, 2 by 3. Yes. Let me draw here. The equivalent value is 40 by 3. And this is 2 by 3. and this is 5 ohms. External resistance. What is I? Let us check again. 40 by 3, 2 by 3. 40 by 3, 2 by 3, yes. I is equal to E divided by R plus small r. R is 5 plus small r. This is 40 by 3 divided by 3 into 5, 15 plus 2, 17 by 3. The 3 I am removing. 40 by 17 will be the answer. I is equal to 40 by 17 amperes. We will see the options. 5 by 8, 5 by 3, 40 by 17 option. C is right. Yes, in this problem, the potential difference between points A and B is what? This voltage is asked. VAB is what? Potential difference between the points A and B. Two cells, they are connected in parallel. Yes, this formula we will use again here. Sigma E by R divided by sigma 1 by R, because this is used for the parallel connection. So this problem, this is also a parallel connection. 2 voltage, internal resistance 1 ohms, 4 voltage, internal resistance 1 ohms, 3 voltage and the internal resistance 1 ohms. So this is a parallel connection. For this parallel connection, we will find its equivalent circuit. Let me say this is C. A, B, this point, let me mark it as C. E equivalent is equal to sigma E by R upon sigma 1 by R. E1 by R1 divided by E2 by R2. E1, 2 voltage divided by R1, 1 ohms. If we write plus here, this is wrong. Look at the polarity. This is plus minus and it is minus plus, right? So you have to be very careful. Minus 4 by 1, E by R. Then it is 1 by 1 plus 1 by 1. 1 by the internal resistance, 1 by the internal resistance. That is the formula we have discussed. Reciprocal 1 by R. R value is 1 ohms. Here we must use plus. The resistances, they doesn't have any negative value, right? We should add the resistance values, right? This is 2 minus 4, this is minus 2. 2 minus 4 divided by 1 by 1 plus 1 by 1 is 1 plus 1, 2. Minus 1 is the equivalent value. So this combination is producing minus 1 voltage. So the equivalent circuit will be A minus 1 voltage. So we must take the negative polarity first and then the positive polarity, its internal resistance. This point is C. Then the third battery, third cell, 3 voltage, 1 ohms, B. This is minus 1. So I have taken the negative polarity here. So the value is 1 voltage. R value is 1 ohms and 1 ohms equal value, they are in parallel. So 1 by 2 is the answer, 0.5 ohms. R1, R2 divided by R1 plus R2. This is 3 voltage and this is 1 ohms. The question is the voltage between A and B only, right? A and B, This is minus plus, plus minus. 3 minus 1, 2 is the value. 2 voltage. Option A is right. The calculation of resistance doesn't make any mistake here, right? It is not in the question, but you must be very careful. In other problems, if in the question, if it is required, you must make plus here, right? Next problem, two identical cells, each of EMF E and internal resistance R are connected in parallel. Identical cells E and R. E and R, two cells parallel. External resistance R. To get maximum power developed across R, the value of R is identical. This is the circuit. This is R, E, R. The equivalent value will be, if they are identical, this part I can draw it as E parallel, R will be R by 2. R by 2. And the external resistance R. This is the equivalent circuit. The condition is maximum, to get maximum power developed across R. Across R, what is the value of R? This value will be the equivalent value. It must be equal to the internal resistance value. R by 2 is answer. Internal resistance is R by 2. Option A, R by 2. Next problem. When an unknown resistance is connected across a series combination of two identical batteries of each of 1.5 voltage, the current through the resistor is 1 ampere. When they are connected in series, for series 1 ampere. When it is connected across a parallel, across the same batteries, parallel combination of the same batteries, the current through is 0.6 amperes. The internal resistance of each battery is what? Unknown resistance, 1.5 voltage. EMF is available, two currents are available. Ohmic resistance, ohmic values are not available. Internal resistance not available, external resistance also not available, right? The question is to find the internal resistance. I am using a blank page. They are, first case, connected in series. R, E. Then they are connected in parallel. The question is to find the internal resistance value. I values are given. Internal resistance is question. I values, when they are in series 1 ampere, when they are in parallel 0.6 ampere, it is flowing the current through the external resistance. External resistance is 1 ampere and here it is 0.6 amperes. 1 and 0.6. 1 and 0.6. 1 ampere and this is 0.6 amperes through the external resistance, right? So its equivalent circuit is E and E, parallel combination. This is the parallel group of two cells. Their equivalent value is also E, parallel voltage same, R, this will become R by 2. external resistance R. Current is 0.6 amperes. Here current is 1 amperes. Its equivalent circuit is E plus E 2E, R plus R 2R. This value is 1 ampere. Question is to find the internal resistance, right? Current value, current I is equal to the total voltage divided by total resistance. Total voltage is 2E divided by R plus 2R. E value, I think it is given in the problem. Let us read it again. Yes, 1.5 voltage. E value is available. So this must be 3. I am replacing the E value with 3 voltage. One point five, this is 3. 1.5, this is also 1.5. Equation number 1. Here 0.6 is equal to equation 2 for the second case. 0.6 is equal to 1.5 divided by R plus R by 2, which can be simplified as 1.5. The right hand side only I am simplifying. 2R plus R divided by 2. This 2 will go up. 3 divided by 2R plus R. So 0.6 is equal to 3 divided by 2R plus R. Equation number 1 is equal to 3 divided by R plus, actually this is 2R, I am sorry. R plus 2R. R plus 2R. This is 3 divided by 2R. 0.6 is equal to 3 divided by 2R plus R. So cross multiplying gives R plus 2R is equal to 3. R plus 2R is equal to 3 by 1 is equal to 3. Right. This is 2R plus R. 3 divided by 0.6. This is 30 divided by 6 is equal to 5. So 2R plus R is equal to 5. Equation number 2. This is equation number 1. We have to simplify the 2 equations, 2 unknowns, 2 equations. The question is to find capital R or small r. The internal resistance, small r. So R plus 2R is equal to 3, or I can multiply it with 2R. 2R plus 2 into 2R, 4R, this is 6. 2R plus R is equal to 5. Subtract. 2R minus 2R 0, 4R minus R, 3R is equal to 6 minus 5, 1. R is equal to 1 by 3 ohms is the answer. R is equal to 1 by 2, 1 by 4, 1 by 5, 1 by 3. Option C is the answer. Yes. In this problem, here, two cells A and B of EMFs, electromotive forces, 1.3 voltage and 1.5 voltage respectively are arranged as shown in the figure. The voltmeter assumed to be ideal. The voltmeter assumed to be ideal. Reads 1.45 voltage. The voltmeter reading is 1.45 voltage. definitely we know the voltmeter will read a lesser voltage than the available voltage, but here this is a group of cells, two cells are connected, so that is why it is reading greater than this cell and smaller than this cell. Let us check what answer it is coming. The voltmeter assumed to be ideal, reads 1.45 voltage. The internal resistance of cells A and B are RA and RB respectively. Which of the following is correct? The options given are RA is equal to 2 times of RB, RA is equal to 3 times of RB, RB is equal to 2 times of RA, and RB is equal to 3 times of RA. Voltmeter is an ideal voltmeter. Voltmeter is here connected just to measure the voltage between the two cells, right? So voltmeter is ideal means it is an open circuit. Ideal is equal to open circuit. That means it will not take any current for its operation. The current through it is zero. Just it is showing the voltage between these 2 points. So I am going to redraw this diagram for better understanding. Cell 1 RA, cell 2 RB. This value is 1.5 voltage. Cell B, cell A is 1.3 voltage. Ideal voltmeter, so I am showing the dotted line. Instead of this voltage this is showing 1.45 voltage, I am using a dummy battery here. This is one dummy battery. So I am connecting a dummy battery here because voltmeter is reading the voltage available across it. Any voltage which is known at a particular place, after making some calculation, we can connect a dummy battery. Already in a video, Kirchhoff's voltage or Kirchhoff's laws, we have used this concept, dummy battery concept. Dummy battery concept means it is assumed as a battery or a cell, but it will not send. Please remember, it will not send any current, right? No current will be sent by this battery. No current is passing through this battery, right? Because it is an open circuit, ideal voltmeter. Through the open circuit, how a current will be flowing, right? So the dummy battery is just for calculation. We are assuming a battery is connected. Since it is a dummy one, it will not send any current into the circuit, right? So the entire current will be circulated by the two EMFs which are available 1.3 and 1.5 respectively, right? So this one is the bigger one, so I am assuming this current in this direction. Only one current it is flowing. It is entering this battery here, this cell here, entering, leaving, then it is coming here and coming here. Then it is circulating this way. So the polarities are very important, plus, minus, plus, minus. Then I am going to use Kirchhoff's voltage law twice for the upper part and for the lower part, right? I am going to use the Kirchhoff's voltage law. Two voltage laws I will write. The first one, upper part. The second one, lower part. In both the parts, the 1.45 will be connected. This voltage will be connected, right? For the upper part, let me draw a separate circuit. This is dummy battery, so let me draw is a dotted line. 1.3 and RA. This is 1.45. The current entering is plus, leaving is minus. So the voltage across it is IRA. Similarly, the voltage across it is IRB. So for voltage, Kirchhoff's voltage, to apply Kirchhoff's voltage, we need voltage across it, right? So now we are writing the Kirchhoff's voltage law. This is the current I amperes, right? From here, let me start 1.45, 1.3 plus 1.3 plus 1.3 plus I into RA plus I into RA minus 1.45, this is minus, is equal to 0, equation number 1. So I into RA 1.3 minus 1.45 is minus 0.15 is equal to 0. So I into RA is equal to 0.15, equation number 1. Similarly for the lower part, right, plus 1.45, you can start writing the Kirchhoff's voltage law at any point of your wish, right? Let me start from here, right? Plus 1.45 plus I into RB minus 1.5. Look at this. First I am entering the minus terminal. Minus 1.5 is equal to 0. So I into RB is equal to plus 1.45 minus 1.5 minus 1.5 is bigger. So 0.05 minus 0.05 is equal to 0. I into RB is equal to 0.05. Equation number 2. IRA is 0.15. IRA is 0.15. IRB is 0.05. This is equation number 1 and equation number 2. 1 divided by 2 is equal to I into RA divided by I into RB is equal to 0.15 divided by 0.05. I removed RA divided by RB is equal to 0.15 divided by 0.05. 15, this will be 15 divided by 0.5. This is 1.5 divided by 0.5 or 15 divided by 5 is equal to 3. RA is equal to, so the condition is RA is equal to 3 RB. This option is true. RA is equal to 2 RB, RA is equal to 3 RB is true. RA is equal to 3 RB. RA is equal to 3 RB is correct. Yes. Next problem, maximum power developed across variable resistance R in the circuit shown in figure is. What is the maximum power developed here? This R, all the 3 branches, branch 1, branch 2, branch 3. In branch 1, one cell is there. In branch 2, external resistance is there. In branch 3, another cell is there. I can easily redraw it as, for simplicity, nothing wrong, because this is a parallel connection. This is a parallel connection. This is a parallel connection, right? This is R, external resistance. This way also we can draw it. 10 voltage 1 ohm. 10 voltage 1 ohms. 10 voltage 1 ohms. Right? Question is maximum power developed across variable resistance R is. To find it, we have to use the formula I square R. Power is equal to I square R. So I must be found first, right? For it, I am going to draw the equivalent diagram. 10 voltage and 10 voltage, equal values. So the result will also be 10. No need to use this formula. E equivalent is equal to sigma E by R divided by sigma 1 by R. Even if you use it, you will get the same answer. Equal values, you can directly write it is 10. E equivalent is 10. For unequal value, this formula will be very helpful. 1 into 1 equal values. So this will be 0.5 ohms, 1 by 2. Then our external resistance R. This is the variable one. Yes. So this is variable one. You can vary this value. What value you are going to set? That is the question. Then once it is found, it is not the question. Power is the question. So right, you are varying the resistance and fixing the resistance for the maximum power. And what is the maximum power? Right. I square R. So to get the maximum power, R must be also 0.5. That is the condition just now we have seen. R must be equal to the internal resistance value, right? So the question is to find the maximum power, we need the I value, right? So P is equal to I square R, then I is equal to E divided by 0.5 plus 0.5, 1 ohms, so 10 ampere. Then the 10 will be put here. P is equal to I square, 10 square. R value is 0.5. So this is 100 into 0.5, 50 watts is the answer. Option A. Hundred cells each of EMF 5 voltage, 100 cells. EMF 5 voltage, internal resistance 1 ohms are to be arranged so as to drive maximum current. Maximum current must be obtained from the cells. Say battery, 100 cells we have to arrange. It must send the maximum current. Again maximum power transfer theorem. In here 25, the external resistance R is equal to 25 ohms. Each row is to contain equal number of cells. We are forming different rows. Each row must contain equal number. Each row is to contain equal number of cells. Unequal number of cells should not be connected. So row 1, row 2, row 3, row 4, right? This is the arrangement. So this circuit is connected to the external resistance. External resistance is 25 ohms. This is the arrangement. How many rows? The question is, what is the number of rows? The total number of cells. This is the battery. Different cells are combined. There are so many rows. All the rows must contain equal number of cells. Together, they must send a current. That current must be the maximum current. Right? For maximum current, its internal resistance value must be equal to the external resistance value. Since the external resistance value is fixed, the internal resistance or equivalent must also be 25 ohms. First point. To have the maximum current from the battery, the equivalent R value must also be the external value. Since it is fixed, we have to arrange all the cells such that their equivalent resistance value is giving us, equivalent internal resistance value is giving us a 25 ohms, right? How to form the cells to form this battery? How to connect the cells to form the battery, right? For this problem, let us use all the options. First, let me assume 4 rows, 4, 5, 2, 10, 4 rows. If I assume I am solving this problem in the reverse order, right? From the answer, I am going to apply all the answers and I am going to find the correct one. 4 rows. If I connect all the cells into 4 rows, 100 cells will be connected as 25, 25, 25, 25. Their internal resistance is 25 ohms. So this will be 25 ohms, 25 ohms, 25 ohms, 25 ohms. 25 divided by 4, parallel connection. 25 divided by 4 will be 12.5. It is wrong because we need 25. Next option is 5. So 5 rows. 100 cells we have to arrange. 20, 20, 20, 20, 20. 20, 20, 20, 20, 20. So 20 divided by 5 is equal to 4 ohms. This is also wrong. So this is not 12.5. This is 6.25. Anyway, it is wrong. This is not 12.5. This is 6.25. 6.25 is wrong. Here it is 20 by 5. This is also wrong. Then I am going to use the third option. 2. Row 1, row 2, 100 cells. I am having 50 cells and 50 cells. 50 ohms and 50 ohms. 50 divided by 2 is equal to 25. This is correct. R equivalent 25. So option C is correct. 50 cells we are forming. We are connecting 50 cells in series and we are forming 2 rows. The equivalent value will be 50 ohms and 50 ohms. Since they are in parallel, 50 ohms and 50 ohms, it is giving us the equivalent internal resistance as 25 ohms. Our external resistance is also 25 ohms. Option C is correct. Option D, 10 rows. 10, 10, 10, 10. The 10 by 10 is equal to 1 ohms. It is also wrong. So this is also from the grouping of cells. N rows, each of containing M cells, M cell in each row, in series or joined in parallel. N rows, row 1, row 2, row 3, row N. So this is row 1, row 2, row 3, N rows. Each cell is having, each row is having M cells. Cell 1, cell 2, cell 3. So this is M cells. In each row, M cells is taken from this combination across an external resistance of 3 ohms. They are connected across an external resistance of 3 ohms. If the total number of cells used are 24, total number of cells, and internal resistance of each cell is 0.5. Each cell, R of each cell is 0.5 ohms. Then M is equal to 8, N is equal to 3, M is equal to 6, N is equal to 4, M is equal to 12, N is equal to 2, M is equal to 2, N is equal to 12. M and values are found. What is M and what is N? M cells, N rows. Total number of cells, 24. Each cell, the internal resistance is having 0.5 ohms. Yes. The EMF value doesn't matter here because it is a maximum power transfer theorem. The external resistance value is given 3 ohms. So these cells, they are giving equivalent internal resistance. Their equivalent internal resistance must match 3 ohms. It must be exactly equal to 3 ohms, right? So that is the condition we are going to use and we are going to find the M and N values, right? Total number of cells 24. First row, second row, third row, nth row. Cell 1, cell 2, cell 3, cell 4, M cells. So the resistance also internal resistance. R. Since it is M cells, in each row, I am having M into R value, ohms value. M into R value. Second row, MR. Third row, MR. Right? So this is nth row. Right? So MR. The R value is 0.5 ohms. So this is 0.5 M. This is also having 0.5 M. 0.5 M. 0.5 M. So each row is giving series. In series, we are adding the equivalent resistance value 0.5, 0.5, 0.5, 0.5, 0.5, m into 0.5, right? So total value will be, since 0.5, 0.5, 0.5 m, 0.5 m, 0.5 m, they are connected in parallel, their equivalent value will be 0.5 m divided by n. That is the equivalent value of the battery, not the cells, right? This is the battery. After they are grouped, we are getting the battery. Yes, this is the equivalent circuit, equivalent value. This can be written as m divided by 2n, the equivalent value. It must match the 3 ohms external resistance, right? This is one equation. M 0.5 m, 0.5 m, 0.5 m, 0.5 m divided by n. 0.5 m divided by n is written as m by 2n, that's all. The equivalent value will be 3 ohms. 3 is equal to m by 2n, right? Then total number of cells 24. M cells 1, 2, 3, 4, 5, 6, 7, 8. If I count all the cells, the last cell will be 24. That is, if you assume this is one matrix, 1, 2, 3, 4, 5, 6, and the last cell value will be 24. That is, m into n should be 24. This is equation number 2. Equation number 1 and equation number 2. Two unknowns, m and n, two equation, we can get the answer. So this is m by n is equal to 6, cross multiplying. M by n is equal to 2 into 3, 6, or m is equal to 6n. If you substitute 6n here, mn is 24, m is equal to 6n, 6n square is equal to 24, n square is 24 by 6 is equal to 4, n is equal to 2, n is equal to 2. If n is equal to 2, m is equal to 12. M12, N2, M12, N2, option C, M12, N2. Yes, this problem. 12 cells of each EMF 2 voltage. 12 cells, their EMF value is 2 voltage, are connected in series. Among them, 3 cells are connected wrongly. Wrong connection. What will make if we connect any one cell wrongly? This is a conceptual problem. First, let me discuss the concept. Yes, 3 cells I am taking. This is 5 voltage, 5 voltage, and 5 voltage. This value will let us say this is 1 ohms, 1 ohms, 1 ohms. The equivalent value will be the two ends are A and B, plus minus, plus minus, minus plus. Only one cell is wrongly connected, right? So this minus, this plus minus, and this plus minus. This combination will become 0. So the equivalent value will be 5 voltage. This value will be 3 ohms. 1 plus 1 plus 1. The resistance value will not be cancelled, but the voltage value will be 0. 5 voltage, 5 voltage, plus minus, plus minus. If we connect one of the cells as wrongly, it will cancel another cell's value also, equal value, right? If it is 15, it will consume only 5 voltage. So remaining 10 voltage will be the answer, right? But in this case, since it is equivalent value, the equal value of another cell will be cancelled. 12 cells of each EMF 2 voltage are connected in series. Among them, 3 cells are connected wrongly. 3 cells wrong means effectively 6 cells or cancelled. Six cells voltage only must, this point is important, only the voltage, resistance will exist, right? So that means 12 cells, 6 cells are cancelled, so remaining 6 cells are there, 2 voltage, 6 into 2, 6 into 2, 12 voltage will be the answer. For wrong connection, that will be the concept. 8 identical cells, each of EMF, 8 cells, EMF E, internal resistance are connected in series. If polarity of 2 cells is reversed, that is wrong connection, then the total internal resistance, so already I told you, internal resistance will not be cancelled. 8 cells means 8R. 8 cells means 8R. But if voltage is asked, suppose if voltage is asked, if polarity of 2 cells means it will cancel another 2 also, 2 plus 2, 4, 8 minus 4 is equal to 4E will be the answer. If it is asked, 4A will be the answer. But here the voltage is not in the question, only the resistance 8R will be the answer because all the resistance will exist. 4 cells, each of EMF E, 4 cells, E, internal resistance R, are connected in series across an external resistance capital R. By mistake, one of the cells, only one of the cells is connected in reverse. Then the current in the external circuit, one cell is wrongly connected, it will spoil the other cell's voltage only. Other cell's voltage only. 4 cells, one cell is wrongly connected. 1 plus 1, 2. So 4 minus 2, 2E is the net voltage. Net voltage. Current is asked. I is equal to net voltage divided by net resistance. External resistance is R. Internal resistance will not be cancelled. 4 cells means 4R. This is the current value. 2E divided by R plus 4R. 2E divided by R plus 4R. Option A. This is 3E, this is 3E, this is 2E. Right. In this problem, there are n cells, each of EMF E and internal resistance R connected in series with an external resistance R. N cells. E, R, external resistance R. One of the cells is wrongly connected. One cell is a wrong cell, so that it sends current in opposite direction. Yes. The current flowing in the circuit is what? N cells means N minus 2E. It is not NE. If all the cells are connected correctly NE, if one cell is wrongly connected, it will spoil the near other cell also. So not N minus 1, N minus 2E. The net voltage is N minus 2E. Current is asked. I is equal to what? I is equal to the net voltage is N minus 2E. The internal resistance will not be disturbed. N means NR. External resistance is capital R. N minus 2E. This is N minus 1E. This is N minus 2E divided by NR plus R. Option C is right. Here N minus 1E. N minus 2E, this is also wrong. N minus 2 of R plus R. Yes. So this is the end of this lecture, guys. Thank you for watching. Good luck.